all good.
Okay, so welcome everybody. And as you can see, I started this podcast because a lot of my students pushed me to talk, and I started this one to just interview other people. So I end up not being talking. So I want to invite Megan, one of my students, and thanks Megan for coming today.
Yep.
So finally, I can be the one who's talking, and you will be the one hosting the show. So
Okay.
Yeah.
So I think a big question is that I personally wanted to ask was regarding the difference between data science and data analytics, and because last summer I had that data and AI internship, and what I think the difference is data science is more predictive analytics, whereas data analytics is more let's find some actionable insights from the data that we have here and visualize it and present it to someone else, because that's basically what I did. I never really got an introduction to data science. So what do you think the biggest difference between those two would be?
I think data science is very inclusive. So every time you use a data analytic skills or data engineering skills or even big data machine learning skills to solve a problem using data, basically it's called data science. So it's very inclusive. I think there are several differentiations. Maybe you want to make a difference. The first one are the job titles. So there are some job called data scientist, there are some job called data analyst, and there are a third type of job called data engineering. For data engineering, it's aiming more at computer science majors. Basically what you do is you do the infrastructure of big data, how to save the data, how to stream the data, how to pull the data, how to make sure you can actually access to the data, or write some algorithms to find some easy mean value regressions and all these kind of softwares. So that's more like data engineering, the infrastructure. For data analytics, it's more about traditional statistical approach to data problems. You do regression, you do analysis of variance, and you build predictive models and use statistical skills to get report or do the prediction or make some inferences. And when we talk about data science, it's more inclusive. It's more about, I do not do a specific statistical model or anything, but what I do is I give you a business problem, like say, hey, help me to find all the customers from Facebook I should target. I'm talking about millions of people here. How can you design an algorithm which can recognize them? How can I actually design an end-to-end process that can actually do the whole thing, starting from I give you a business problem and finally you give me an answer. Okay. So you use data analytics in the way, you use data engineering in the way, you work with data analysts, you work with data engineers in the way, but your focus is more about seeing the problem, think about how to actually solve the problem with data, okay, instead of just like skills or process.
Right.
Another thing you probably want to differentiate is actually when people talk about data science, the job title doesn't mean anything, because you can have people who are hired as data scientists, but then they go there, they say, hey, generate me a report. And the moment you know, okay, that's not what data scientists do, that's data analyst.
Right.
So you're asking the wrong thing. So a lot of people put titles as data scientists, but they're not doing data science.
Well, do you think it's just because it's so new, they just don't even know what it really is?
Like, it's a fancy word, just like AI. Everybody want to claim I'm doing AI, I'm doing machine learning, but you write a neural network, you claim you're doing AI, doing machine learning.
Right.
Well, that's like you're doing 1% AI, but it's not real AI, So it's the same thing with data science. But when I hear about data science, I'm more thinking about it's not a traditional statistical approach. So we do have other ways to get information from data, which is not by the traditional ways trained in statistics major. For example, like we use regression trees a lot, and we do use decision trees, random forest. We use a lot of machine learning algorithms. Most popular one are the neural networks. Okay, and in traditional statistical approach, you don't do that. And also the problems are usually bigger. When you see a data scientist doing some problem, it's very rare you're going to see, hey, this is on 500 samples. Usually it's like 500,000 samples, or like a daily streaming of 2 gigabytes per minute or something like that. So what you care about is actually to differentiate between this kind of small statistical traditional problems to real data science machine learning problems. And that's what I more think when you talk about data science seriously. And then you need to actually think about bigger scale problems.
Okay.
Yeah.
So when you talk about machine learning, does AI relate to that at all? Or do you think that it's more relative to a different subject matter?
So let's say like AI is, first, I'm not an expert in AI.
Right.
I know a little bit about it. I read about it. But AI is more about how to create intelligence by human. Basically, we let computer do what we can do, including language, including perceptions of pictures and videos, and all this kind of stuff. And eventually probably, generate intelligence and probably something with consciousness. That's the big debate. Like, can the machine think? Are they going to kill us? Yeah. Right, those kind of things. That's more like AI, artificial intelligence. during the past, AI started, I think, in the 1950s, roughly, and the first approach is actually expert system. That is like, okay, I teach that. Basically, what I do is I knowledge engineer everything I know about a game. For example, you teach AI to do something, right? What you do is actually, this is how I do it. Then I actually write down the process. If you see this, do that. If you see this, do that. That's going to be a big knowledge base. Kind of makes sense here?
Yeah.
And then after that, basically, you just code that thing into a computer and say, hey, just imitate whatever I do based on what I know. So that's called expert system. Okay? That's good. You need field experts to actually tell you how this system works. But the problem here is like human only knows so much. When things get complicated, for example, you got 10,000 different cases, your brain cannot handle that. You don't have a recipe for, more than 1 million cases or possibilities or data. So after a certain point, you kind of give up. That thing doesn't perform so well when things get complicated because human knowledge are limited. So that's actually the next approach, which is called machine learning. So machine learning is one type of way to do AI. Okay, I would think in that way. And then what you heard about neural network is actually one model that can do machine learning, but there are other models which can also do machine learning. Mm-hmm. And then deep learning is actually one type of neural network. There are other type of neural networks. So it's kind of like it's like general AI. Part of it is actually machine learning, and part of machine learning is actually neural network. And finally, part of neural network is deep learning, because that's actually the inclusive relationship. So for machine learning, this is another interesting approach. That is, when things get super complicated. Let's go back to the statistical approach, right? You want to run regression. You want to run a linear regression. How do you know that your linear model can capture what's in the data? Well, you plot something called, you check the residue, see if it's normal distributed. You do something called like a QQ plot. You probably have some test for that. That is great, but that thing fails when you have more than 5 variables. It's just like after 5 variables, if you see nice QQ plot, you cannot assume anything because anything can happen. So that thing only works for small data set. That thing only works for a relatively easy data. Mm-hmm. Now, when you have 10,000 variables, when you have 2 million samples coming in, okay? So instead of design the whole thing and try to interpret everything by expert, what you do is you just design a algorithm which is capable enough to capture the pattern, but it's so complicated that you couldn't even understand what's going on inside, but it's capable enough. And after that, what you do is just feed it a lot of examples. And after a while, after you feed it 2 million data, 3 million data, suddenly that thing just learn how to predict. Even though you cannot explain what's going on in the model, but that model worked. So that's a very different mindset. It's a very, very engineer-oriented mindset. So if you think about machine learning, you should differentiate between the old expert system, which is called knowledge engineering, and the new thing is called data science or machine learning or big data. It's basically feed the data and let the model do its job instead of teaching the model what to do.
Okay. Yeah, because when everyone says, this is what artificial intelligence is, I pretty much only hear, teaching a machine human-like qualities or how we would do it as humans. Mm-hmm. But I haven't really seen an example of how that would be in the workplace, right? So what would be a real-world example of using artificial intelligence to solve a problem?
Okay. So I think when people are thinking about using artificial intelligence, there are 2 ways. The first one is just like, general intelligence. Then you use artificial intelligence to build robots, this kind of systems. Yeah. But there are another kind of artificial intelligence. When people say that, people basically means machine learning. Okay, so I can give you some examples. So think about when you start a business. Usually a general business actually take 5 stages. Mm-hmm. The first one you do is actually you are the owner. Like you start a little store, you do everything. But it's not so efficient. What if you got sick, right? You just close the store. After a while, you find there's something I do as an owner which is so redundant, right? What I want to do is actually design a process. And then this is called dedication. I hire somebody, I give them a manual, and just say, hey, go ahead and do it. As an owner, I don't have to do it. In this way, you actually scale up. Think about the teller at the bank as an example. Does the owner of the bank have to do the teller job? No. But at first, of course, you do it, right? Mm-hmm. Once you're big enough, you start to hire people to repeat that process. The third stage will be called digitalization or automation. It's basically replacing all the tellers by ATM machine. Right. So now it's actually cheaper. And it's actually nothing new. Basically, you just automated everything. But you have been already doing this. You're just doing it with machines now. And it's actually better customer experiences in general. Now, the next step is going to be data analytics. So think about Toyota, for example. Like Toyota knows how to build cars, right? Once you build the first car, the next thing you want to do is actually, how do I improve my product chain so it's cheaper to build a car, or for the same cost, it's the better quality? What you do is actually you conduct something called data analysis. Basically, what you do is actually, hey, what if I build a Corolla, let's say, with a smaller tire, so I can save some cost. Mm-hmm. But then people may actually don't want to pay the same amount of money to buy it because it's a smaller tire. Well, let's do experiment. So through collecting a lot of surveys and everything, you kind of get an idea like, okay, what this is going to be. You start to collect the data and then run the model and then make a prediction. After that, you actually validate your model by actually doing it. If your model is really promising, right? Yeah. Actually do it and then collect people's feedback to validate, did they actually really take that car with the same price, even though with a smaller tire? In this kind of way, you make one part of your product chain much more efficient. You repeat this process for every single stage of your product chain. So finally, the whole thing got so automated and so optimized. That's why Toyota can sell cars with same price but much better quality. Mm-hmm. Okay. Now the next level, other than in addition to data analytics, will be machine learning. That is basically automating the data analytics. Like you have analytic teams, great. How much data can they handle? Well, probably 10,000 data at the point with 40 people running models on it, probably with 30 variables. And you have done this in my classes before, right? When you have this many, what do? You subset. Yeah. Right? You subset and say, hey, I scale up. Well, you got the idea. Now scale up, but we don't know how to do it. So after a certain point, you figured, okay, first, the data is getting ridiculous. The variables, there's no way my human mind can process that. But the machine, think about it. If the machine is fast enough, they can monitor 10,000 variables at the same time. Yeah. They can see what you cannot see. Much bigger capacity. Second, if you can also automate the process of reflecting or validating your model, that is, let's say you are in a group and you say, we want small tires. What do? You actually do something with your, do some experiment and then talk with your manager, and your manager set up a meeting with the manager from the tire group, and the tire group will probably need to involve another department. So you got 4 departments got involved. Once you realize, okay, what's going on, you finally figure out what's going on. 6 months passed. After that, another 3 months to see how the customer is going to respond to this, right? For big companies like Facebook and Google, this is too slow. What they want to do is actually figure out what can improve my, for example, like sale, and then do that thing right away if you think it passes a certain kind of quality control or like a risk analysis, and then collect the feedback right away. Depending on the feedback, make some decisions depending on the feedback. If it's working, do more. If it's not working, think about it or reflect or find a human expert. So can you see the data analytic part is actually automated? Right. That's actually what machine learning really is when people do this in real life. So if you think about some examples, let's just take Google, right? So how do they do the page ranking? Like every time you search something, the first one is almost like the one you want to search. Right. How do they do those kind of rankings? They actually get it from massive data. They use a machine learning algorithm to learn it from millions of people who are using Google surveys. What's your first search when you see that thing, right? And when you see enough, their models start to capture those kind of pattern. Then they start to use it. So that is more called machine learning. Can you imagine you hire one guy, just say, hey, here are all the people searching history. Now design a system for me to do the ranking. No. Right? Even a group of guys cannot do that. No. But a machine can. But you need, of course, so instead of building a machine and you're teaching the machine what to do, you actually teach the machine how to learn to do. Mm-hmm. And then after that, let the machine learn by itself. So you don't have to tell them what to do. They will learn by themselves. You design things at a higher level. Okay. Mm-hmm.
With your example about replacing bank tellers with ATMs or stuff like that, that kind of got me thinking about the idea of automation and robots. Mm-hmm. So the big question that, when I read articles about that is, yes, they can do exactly what a human can, if not more, but what about the emotional aspect of dealing with the customer? What about the relationships that they can't build? The communication that they can't?
That's an interesting question because it's simple. The answer simply is no, they cannot do that. Right. And even if a machine can do whatever a human does, people still want human touch. Right. Like when I order, do I want to order towards a screen? Sometimes if it's fast food, if I go to a really decent restaurant, I'm expecting to get serviced by some decent waiters or waitresses, right? Think about elder cares. Like, do you want to talk to a nurse or do you want to talk to a robot? Basically pretend it cares. But here the problem is these are actually the jobs people think will not be automated easily. So we do have a lot of needs for those kind of jobs. Mm-hmm. And there is a lot of artificial intelligence experts are calling out to say, hey, people, if you want to train your kids, you probably want to train your kids more on their emotional people skills and all this kind of part. Because in general, your intelligence part is going to be taken over by machine. Mm-hmm. So that's one aspect of the trend right now. To understand this, I think a lot of people get confused with they actually mix the concept of intelligence and emotion. They're totally different things. In your brain, there are different things. So your brain has kind of 3 layers, right? The very inside one is actually the reptilian brain, which is the part take care of which is the part you share with reptiles, and the other part is actually the old mammalian brain, which is the part we share with rats, the part we share with other mammals. And then the very outside is actually the new cortex. That's actually the part human is super special because we have such a big new cortex, and that is actually the part who take care of the cognitions. Okay, so that's the part where we differentiate from the animals. We have intelligence. But actually your emotion is not controlled by that part. Your emotion is actually controlled by the first two layers of your brain. Mm-hmm. So actually we share our emotions with rats, believe it or not. So from here you can see what we're trying to do with computer is actually we're trying to replicate what the third layer can do. We haven't touched the second and first layers here. So a lot of people say, hey, when the machine becomes smart enough, they're going to start to have feelings. No. If you don't code them to have feelings, they won't have feelings. This is what I believe. Mm-hmm. Okay, because you don't get that thing automatically simply because the intelligence system and the emotional system are two different systems, even in our brain. They use different models. Of course, they interfere with each other. For example, sometimes you're emotional. You say, I cannot think, right? Or sometimes you don't have to experience something. You just think about something, suddenly you got mad, right? That's actually the part when your intelligence and your emotion are actually interfering with each other. But actually, machine is only going to replace the intelligence part, as far as I know. Well, unless you actively to code them to have emotions.
Right, but you could code them and say, if this happens, the circumstance, like if someone says something, then do this. Right?
That's more like intelligence instead of emotion, right? Emotion is more about how they feel, how the machine feel. Kind of makes sense here. A lot of people get confused, like how, for example, take Turing test as example, right? How do you know if a machine has intelligence or not? Well, all the approaches I know so far is actually they attack the problem from the behavioral perspective. That means if you act like you have intelligence, I think you're intelligent. Mm. Actually, I don't care do you understand the thing or not, but if you act as you have intelligence, I'm going to think you have intelligence. Do you experience that? I don't know. Do you have love? If I cannot tell the difference, then you have love. But if you think about it, you don't care about the internal structure. You just care about, do you look like you have love? Right? So that's actually what people are seeing. And I think this, if you just think about things from behavior point of view, you're missing some part. Actually, you need to care about, do they really feel what you feel? And to do that, I strongly believe that we need to have a theoretical model of the brain figured out. Instead of just saying some machine can do some stuff, but you heard this, right? It's like zombies. Do exactly what we do, say things they say, but they don't mean it. Right. They're just repeating. Or they're just creating something which follows the grammar and everything. Even though that thing sounds like emotional, actually, they don't have emotions. And you need to also differentiate between, like, sometimes you think a machine has emotion, but actually it's not machine has emotion. It's actually you think machine has emotions. You are projecting yourself onto the machine. And you don't need actually the machine to be smart to do that. Just think about if you go somewhere. I show this video in class. You have a robots or like a robotic dog. You just go there and kick the dog, robotic dog. Our people is like, oh, so you already have sympathy with the dog, even though you know the dog is pretty stupid because it's robotic. Yeah. It cannot even bark. But somehow you just feel bad, right? But sometimes people get confused, like, is that because the machine has emotion? No, it's actually because you have emotions. So you need to actually differentiate very different between intelligence and emotions, and also behavior and internal, and finally their emotion or actually your emotion. It's very, very different.
Interesting.
Yeah.
So going back to the idea of big data, do you think that big data is the basis of data science? Like, do you need that to construct algorithms, do statistical processes and stuff like that? Because when everyone says big data now, it's pretty much revolving around data science. Is that correct?
I'd say like data science, of course, involves small data science, right? We just don't call it data science, but if you have a small data sample, you do it with data approach, you can call yourself data science. But if you talk about big data, so basically this is what you should think about. Whenever you try to build a model with data, right? A traditional statistical approach is doing the following. Basically, you have some data. You want a model which can describe, capture the pattern inside the data, and finally use the data to make a prediction. Use the model to make a prediction. Mm-hmm. We're talking about supervised learning here. Of course, we have other type of models, but usually we do predictive models, right? So in traditional statistical approach, what you're trying to do is you're trying to pick a model complicated enough so the model can actually capture the hidden pattern, because the hidden pattern can be complex, right? If you pick linear regression for everything, for some data, it will work. For some data, it's just too simple. You cannot capture it, right? But so you want your model to be complicated. Meanwhile, do you want your model to be overcomplicated? If you do that, we actually see something which is called overfitting. Your data is so complicated that it fails to generalize. It basically memorizes what happens in your data. If you test it with any data you have seen before, 100% accuracy. But if you capture anything which it hasn't seen before, it's very low accuracy. So what you have here is actually you basically recited the whole book. But how do you claim that, for example, in calculus, you recite the whole book, all the homeworks. Do you think you understand calculus? Well, you overdid it. You actually failed to generalize. So the traditional statistical approach is actually trying to pick a balance, the best model, which is just right, not too simple, so that thing can capture some complicated pattern, but not too complex so that the parameters are so hard to estimate.
Okay.
Kind of makes sense here?
Yeah.
Big data have a third component. That is, even if you pick the right model, it's just right. Okay, you have a nice balance. It's very possible when you try to estimate the parameters using some optimization algorithm, that algorithm never stops, never converges. It will take you 10,000 years to finish that thing. So if you pick a perfect model, but it takes 10,000 years to run, what's the point? So actually you start to have a trade-off now in three things. How simple is your model? How complicated is your model? And how long does it take to run? Kind of makes sense here? So the current neural network machine learning algorithm is basically the following approach. Number one, pick the as complicated as you can. Okay, make it super complicated, the model. And then, because the model is so capable, it needs a lot of data. Otherwise, you have overfitting. You just simply memorize all, right? Until a point you start to say, hey, now I'm not memorizing because even for me, with such a big brain, I cannot memorize anymore. I need to actually start to find a pattern. That's why you need a lot of big data. But then when you have a big data, you can see automatically your computational efficiency become a super important issue. So when you deal with data science, you think a lot of things which you do not think in statistical approach. For example, if you run linear regression, you find that your alpha, beta, gamma. It's very possible that your algorithm just stuck there. Now I have 10,000 variables. It's just like, sorry, out of memory. Every time you run it, is it because I picked the wrong model? No, it's just your model never stops. So let's do some trade-off. So when you do data science, big data, you start to think about efficiencies, you think about storage, you think about data backup, security, and all this kind of stuff. Okay. And also, of course, big data is, if you think about data science as the engine of a car, big data is basically the big availability of big chunk of samples are basically the fuel. Without fuel, you cannot go anywhere. Okay, that's why actually big data becomes super big now, simply because, first, we do have the capacity to collect a lot of data. We have sensors everywhere. You take out your iPhone, that's a sensor. Audio, video, location, GPS, right? And whatever data is there, it's actually sensor everywhere. And then we did develop the infrastructure for storing those kind of data, backing up those kind of data, and streaming those kind of data, even before I analyze anything, right? And after that, of course, now you have the data collected, you have the data stored. Now let's do some model on that. That's actually where data science come from, not data science, where big data concepts come from. It's like you have this much chunk of data ready. Don't you just want to do something about it?
Right.
Right.
But some companies don't know what to do with it.
It's really hard because, like I said, this thing takes 5 stages. Usually, the companies who does machine learning really well, they went through everything before that stage. So that means they did digitalization. Now, if you look around, how many companies haven't collected the data or stored the data on cloud base yet? Right? They don't even have a database. Then how are you supposed to do machine learning?
Yeah.
Right? After that, if you do analysis, right? If you haven't done any analysis, you just have a database and say, hey, I want to do machine learning. How do you know that if you build a machine learning algorithm, that can give you some result? Does the result make sense? If you haven't done this manually before, you couldn't tell. Right? Think about it. If you try to automate the data analytics, right? You just try to automate some analysis you have done 500 times before. You know if this happened, now the scale is just bigger. You cannot handle it. Now your machine takes it, give you some idea, or output, and you look at it, you say, hey, this makes sense. Why does it make sense? Because I have done this manually before. Right? So that actually, if you jump right from digitalization to machine learning, skipping the data analytics part, you're taking a very big risk. Because even though you have the result, you don't know if it's good or not. Because your team just don't have the experiences. So if you think about it, all the big machine learning companies, like Google, Amazon, they're way past digitalization. They have actually done digitalization on the last wave. They have done a lot of data analytics from the last wave, and now they're ready to do machine learning.
So are you saying they're ready to do it based on their previous experiences?
Basically, one thing built on another. You can still skip some steps in between, but it's just it's a very high risk. And if you think about when a company hires machine learning expert, it's super difficult. So number one, usually these guys are working at big companies.
Yeah.
Okay, it's hard to hire them.
Yeah.
Number two is if you hire them to do exactly what they did back at the company, and they have actually directed the whole product process before, they know, hey, give me this kind of data.
Mm-hmm.
Okay, give me this kind of people who have this kind of skills. Give me this much of time. I can build that thing. But basically, they're doing what they were doing before. That also will work. But if you hire somebody who knows generally about machine learning, but you want him to design something specific for your data, something specific for your company, it's pretty difficult because that thing takes a long time. Okay, and they're pretty expensive. Do you have the patience for them to stay there for 3 years and finally started something may or may not work,
Right.
which basically imitate what you have done before? It's really difficult, right?
Mm-hmm.
You need to give it patience. And sometimes you need to actually build a whole team on that, around it, right? People need to get trained, get familiar with your field of expertise, get familiar with your data, and experiment with things. That thing takes a long time. So it's really difficult for a company to think about that. It's just like, I pay you $200,000 a year, 5 years past. What do you have for me? You know,
Right.
it's really difficult. So that's why this thing, if you want to do it well, it's extremely hard.
Mm-hmm.
You can talk with anybody who does machine learning, especially commercialize the machine learning product. Probably the only comment they have in common is just this is super difficult,
Mm-hmm.
no matter what kind of product you want to make.
So do you think that turns people away from wanting to do those positions?
Actually, people want to do these kind of positions more and more because this is just exciting. The pay is really good.
Mm-hmm.
And it's actually cheaper and cheaper to learn machine learning. Like all these kind of online resources, all these kind of GitHubs, code you can share online. So people actually want to go into this kind of careers, but it's really difficult for companies. I'm not talking about companies with experiences. For example, if you're from Silicon Valley, you know who to hire.
Yeah.
You have heard about this thing enough, so you know what to do. But for general company, it's really hard for them to hire the right person for the right amount of time and make sure he works on the right project and give him the right resource from scratch. It's just difficult.
Mm-hmm.
You need some experiences.
But what's hard is, 10 years ago, we use different programming languages and different ways to do things.
Mm-hmm.
And then now we're doing different things. So that's why people my age, the younger generation,
Yeah, younger than me.
are doing this more so than the other generations.
Doing what most of?
Interested in learning machine learning
Mm-hmm.
and wanting to do jobs like that. So how do you think other generations could be more attracted to it and being able to?
You mean the older generation?
Yeah.
Or actually the younger, even younger than you?
Both.
For younger kids, you don't have to. You just they see it on every smart kid actually follows Google, what happens in Google,
Mm-hmm.
physics, chemistry, all these kind of things. And there will be a group of young people, and they are super interested in this kind of thing. And before you know it, because of the internet, because the online thing, everybody's actually looking for this kind of resources at a very young age, and they can find easy online resource. And believe it or not, they are incredible at coding. Like if you talk to 11 years old, if they have coding experiences, I won't be surprised. I got beaten by 11 years old in terms of coding if they're really enthusiastic about it,
Mm-hmm.
right? So you don't worry about them as long as that thing is hot. They care about it. It's the same thing they care about black hole. It's the same reason they care about chemistry or biology and all this kind of stuff.
Mm-hmm.
Plus, we have a lot of online resource available now, and a lot of big companies, they realize the value. For example, Google. They think the best way to promote machine learning the best way to do machine learning, to prepare more people doing machine learning, is to promote it to younger generation. So they actually give you huge discount if you want to try out things on cloud computing, as long as you are young.
Mm-hmm.
They actually give you all these kind of opportunities to go online or go to actually Google's, satellite office to just go and experience. Like think about a group of high schoolers, just go there and say, hey, this is what we do. We got an expert to just talk with you guys for 2 weeks. Tell you what machine learning is.
Mm-hmm.
So I'm not worried about young people. For older people, it's kind of harder because number one, like you are familiar with your programming language and your daily job and everything. You don't see the necessity of doing this, right? So for that case, you don't have to care about it. If you really care about it, I think there are learning barriers. Like if you're not decent in mathematics, you can only go up to this level. If you're not decent in statistics or programming, there are only like a limitation or ceiling you can go, unless you're really willing to go back and do your foundations, which is extremely hard for people with a older age. But you can think about how you can contribute to a company or a business model using machine learning. Like machine learning is not like everybody got laid off. We only need the machine learning experts. No, everybody's still here. It's just we bring things to the next level, or the things we used to do by human now is done by machine. So think about who is going to actually direct the machine, who is going to use their experiences to adjust or give advices to machine, to evaluate the process or outcome of the machine, to translate the output of the machine into business model, to tell people actually based on the output what we should do as a business. And also from the other side is actually how do we process the data in a meaningful way so the machine can process it faster and better, right? You can prepare the data for machine. It's just like you're not running the model yourself. So I would suggest, like, if you have a lot of experiences in working in any field, don't be afraid. Like, if machine learning comes, just think about how to work with it instead of saying, hey, being replaced it or just reject it like you're replacing me. No, I'm going to say no to that. Actually, it's not. It's more about like collaborate together. So you need to know a little bit about what machine learning is. You probably don't have to know the algorithms. You know what it can do. You know some terminologies when people make presentations. You know how that thing can benefit your business. And really, if you have to do some machine learning, just hire somebody to do it. Like, you don't have to do it yourself. Just make the right request, and they will produce the thing for you. But you need to make the right request.
So how does cloud computing relate back to that? Because I saw you mention that earlier, and I have no idea what it is.
So so think about traditionally, right? Your computer has a processor. The computer has a hard drive. How do you get better how do you get faster computing and bigger storage? Well, buy more processor, buy bigger hard drive. Up to a point for companies, this is really hard because think about your company as an internet company, right? You just started something called Snapchat, but this time you don't have Snapchat. You call it Snap Talk, right? Snap Talk. And then what you want to do is I want to start to back up all the data, analyze all the data, and how much machine should I buy? Well, 20 computer is good enough. 30 computer is good enough. Not only I need to buy these kind of machines, right? I need to actually hire the IT people to maintain the whole machines. I need to actually make sure that thing is waterproof, fireproof. And I probably need two places so that thing is backed up in case there's a tornado or hurricane or anything, right? Once you get everything prepared, that's already a big resource invested. Okay, you find two things. Number one, my company just growed. Now I need 200 machines. Okay, I just set up that thing. Now do I want to migrate the whole thing? Second, well, I did set up this thing and it's working now. But what did I want to say? I lost track of that. Okay, so you set up the thing. Suddenly you realize you need a bigger machine. Well, I forgot. But either way, okay. So what's the better way of solving this? Well, think about this. So Amazon actually was one of the company who does this earliest, which is like the cloud computing platform, right? So basically what this is, the second thing is, I figured out. So let's say everybody use this app, which is called Snap Talk at Saturday night. At Saturday night, you could probably got 1 million people use it. On weekdays, however, you probably only have like 20 people use it. Let's think about extreme cases, right? Then all your machine, how big do you want your machine to be able to handle, your server to be able to handle? You probably want to handle 1 million people because at the peak time, 1 million people visit your server, right? Mm-hmm. But in general, a lot of them are wasted on weekdays because they are basically idling there, doing nothing. Kind of makes sense here? So it's actually a waste of resource. So what Amazon did was actually this. So we do need a lot of capacity because people shop like crazy on Black Friday, right? But there are like some days in March, some days in February. Basically, my machine is just sitting there doing nothing, okay? But I need to keep them there. So what do I need to do? Actually, I can rent this machine out to other people. When I'm not using it, probably you guys can use it. That is actually the idea of cloud computing. So you do not actually build a machine anymore. Instead of you rent from online, okay? So do you need a 20 machine? Well, just do it. Rent 20 machines. It's probably like $30 per machine per month. Great, right? After that, suddenly I need 2,000. What do you do? Well, just rent 2,000. It's almost like a subscription. Just change my plan number to be above 2,000. Now, $22 per machine. Times that number. You just use it as you need it. And when you don't use it, just close it. So it's very possible for you to actually, run some big machine learning algorithm using 2,000 CPUs for 2 hours. After that, just close them all. And then that machine is going to be used by somebody else. Kind of makes sense here? So that's the idea of cloud computing. You do not have to build your machine anymore. You just rent from big companies. Now, of course, big companies need to take care of all the user experiences, like, for example, how your data is backed up. Like Google, for example, have 3 locations, one in Tennessee, the other one is actually in California, the other one is actually on East Coast. So there is a hurricane, you still have got backups at different locations. Mm-hmm. A single company cannot do that, right? If you're a small company, how are you supposed to have 3 locations? But if you rent from Google, you simply select how many copies do you want? I want 3. Which location? Well, one at East Coast, one at West Coast and one at the Midwest, right? Google does that thing for you. And now if you want to store your data, you need some infrastructures to be done. If you want to query your data, which I suppose you did it with SQL in your intern, right?
Yeah.
You want to query your data, what do you want to do? You basically want to query from the big cloud-based space where basically you don't know what machine it's on. Maybe some of the data is on 3 machines on the East Coast and the other 2 is actually on some machine on West Coast. Google need to actually make sure the infrastructure is working. As long as you go in and type in your account information and you say, hey, I want all this data copied or put into streamed to my machine, that thing got done in no time. So that's basically what they need to do from a software side. Just get the infrastructure done, the backups, the security, and all the IT maintenance, of course.
So can you think of it as just a larger data warehouse to store a bunch of information?
It's basically a data warehouse, but not built by your company. You don't pick the location, you don't pick the machines, somebody else does, but you just rent from them.
Okay.
It's much easier. Think about it. Like if you have a company, right? Probably a whole floor, the 3rd floor is for data warehouse, right? Now, if it's Google, the whole building, or even the whole, the neighborhood can be just all a data warehouse for different companies. You rent the northwest corner of floor 2. That's for your company, right? But a lot of companies actually put everything together. It's so much more efficient in terms of maintenance, security, and also fireproof, waterproof, or even just energy consumption. Right, so that's much better. And plus, every time you do this, think about you basically don't hire IT guy for all the hardware maintenance. Google is doing it. How good are their IT guys? Right now, you just need an IT guy to basically make sure that everything is working from the software side.
Okay.
So that's actually why I think cloud computing is definitely the trend, because I just don't want to buy a big machine to run big models for only an afternoon. Right. How about I just rent it, finish, and then at night at dinner I just close it, and I don't have to pay anything after that.
Yeah. Have you heard of Hadoop?
Yeah.
So what do you think the benefits of using that are?
Hadoop is a very interesting structure. So Hadoop was developed by a guy, I don't quite remember his name, but he usually work with Google to develop Hadoop MapReduce techniques. Yeah. And then he basically came out and started his own company, say Hadoop. So that's why Google is so mad and say, okay, from now on I won't do this anymore.
Yeah.
Basically what it does is it's kind of like a cloud computing platform. You have a master node, which is like your machine, and then you have a lot of slave node. It's basically controlled by the master. So every time you got a data piece come to your machine, right? You say, I set up a Hadoop account, and then nothing actually got stored into 100 or 200 you pick slave nodes. And then basically this is nothing but cloud storage, right? You just store your things on multiple machines, and you can actually retrieve them whenever you need it. But they did something in addition, which is called MapReduce. So think about this. Let's say you want to run the mean value of 1 million samples. 1 million samples was stored in 1,000 computers. 1,000 computers, okay. 1,000 sample each, so you have 1,000 computers. How are you supposed to run the mean value? Well, a natural approach is, now I have everything cloud stored, I copy them back to my machine. So at this time, I'm doing 1 million samples. I found the mean value, finish, and then delete, and say, okay, everybody goes back. Yeah. This is pretty dumb. You still use the advantage of cloud storage, but why don't you think things another way? Instead of copying the data, run the algorithm here, you send the algorithm out. So you have 1,000 machines, each one running a mean value on their local. After that, you got 1,000 mean values. You take it back on your machine and run a mean value of 1,000 mean values to get the final mean value. Kind of makes sense here?
Yep.
So from here, you can see instead of the data comes here, you have the algorithm. Actually, what you do is you send the algorithm out. And on each machine, they run their local little algorithms with their local little biased results, and somehow you figure out a way to combine the result together. For mean value, it's easy. Just take the sum, divide by 1,000.
Yeah.
For linear regression, it's not so easy. For gradient descent or anything we do with machine learning with neural network, the good news is it's very easy to parallel compute neural network models because it's nothing but gradient descent. You really don't care. Do they happen simultaneously together, or actually you can do it piece by piece and then combine the final results. So that's why Hadoop is great. You're sending the algorithm out.
Right.
Yeah.
What do you think the overall benefits are from cloud computing then?
I mean, you don't need to buy a machine anymore.
Yeah.
That thing becomes super cheap. You buy it as you go. You basically buy the service as you go, okay? And it's really easy to scale because you can pick, like if my company is now, I just run 20, but suddenly overnight, my company grow. You can actually suddenly just change your subscription. So that's actually basically a more efficient way to use every resource we have on the planet. Think about same thing with cars, right? If you have a car, are you driving it right now? wouldn't it be better if you're not driving it, somebody else is driving it to make the best usage of it? So it's actually much more efficient. Same thing with computers. If you're not using a computer right now, why don't we just contribute to other people who wants to use a computer right now, right? So a computer got used more. And of course, in this kind of way, we can start to do large computations at the individual level. Even a guy from like La Crosse, like me, at my home, who doesn't have space, who doesn't have money, who doesn't have the knowledge about how to set up a machine learning server, can actually buy something from Google and run something on 10 million samples. That's great, right? You don't want to do it on your local machine.
Right.
Yeah. So that's the advantage. So that's why a lot of companies actually really want that. So you basically don't need a IT. I won't say you don't need an IT team, but a large chunk of what your IT does now can be migrated to cloud, and then that just makes everything better. Yeah.
Okay. Going back to when we talked about automation, I was just thinking about, I don't know if it was you, but someone else showed me an article about how back in China, I think it was, they have these huge...
Must be me.
It's probably you, yeah. They have these huge vending machines that are filled with cars, right? So you go and pick out your car, they deliver it to you, and you test drive it around the block, and you say, yes, I want this, no, I don't want this.
7 days, yep.
Yeah, so you're not actually interacting with the person. It's just automation like we just talked about. Now, if it is a self-driving car versus if it's not a self-driving car, how do you think people would interact with it, right? So do you think people trust the process of a self-driving car? Or do you think they would rather just go to the car dealership, talk to someone, pick out a regular car that they can drive themselves?
So are you talking about the automation of the going to the dealer part, or are you talking about the automation of the driving part?
Both. The whole process.
Okay. So for self-driving car, I mean, Elon Musk painted this beautiful business model. It's just like, where's your car? It's parked right now. So how do you like it? Instead of buying a car, you buy $200 for, 500 miles per month. And then every time you need a car, you just open the app, click, and after like 5 minutes, within 5 minutes, some self-driving car just go there and park at the curb. You go there, you go inside, you click where you want to go, that thing drives you there. And then if you come out, the car just go and pick somebody else up. So it's more like a cloud driving, just like a cloud computing, right?
Yeah.
Everybody's using it, so you don't have to own a car anymore. You just buy it as you buy the service as you need it. So that's a very interesting business model of self-driving cars. Another thing you can think about is actually more than 33% of the traffic in the city is actually caused by people looking for parking lots. Like if your car never parked, you don't need that many parking lots, and you don't need that many cars to look for parking lots, right? So actually, it's a very interesting business model from the commercial side. Now, from the people side, let's go back to like how you feel. No matter how good the machine is, how do you feel about it? So several things. Number one is, what if the machine hits somebody, right? And then what you do is, well, on one side, the machine shouldn't hit anybody, right? It's just like a human won't do that. Human will be able to avoid that. But if you take a second thought, how many drunk drivers are there? How many accidents are actually caused by human who are suck at driving, or actually they're just not responsive drivers? Machine can easily beat that, right? It's like, for example, every year, probably the thing caused by a human driver is probably like 500. The machine is probably just one. But people is going to make a big deal about that one that they didn't do, because the machine are supposed to be better. And then you say, well, I did that one simply because this guy was walking and he was drunk and he was walking at the red light where he was not supposed to be walking, and he was wearing dark clothes and everything. But people are still going to say your machine should be good enough to handle that even. Right? So that's the thing, is just like how we actually have a different standard regarding human and regarding machines. We need to actually make adjustments on that, and I think the government need to play a big role on that. It's like, what's the regulation? Because if you make it clear on that, people will have lawsuit case, people will have insurance, or design it towards that goal, right? It's like how big the responsibility is from the company, and how big the responsibility is actually from the situation. And the next thing is actually something which is even harder, is actually the ethical question, right? I don't remember if I showed it in our class, but let's imagine you buy a car, it's self-driving. The car is trying to pass a red light, and you got 5 kids just walked, which they shouldn't be doing because it's red light, and your car cannot stop. And then your car didn't make any error. Your car just need to make a decision. And now you are a computer engineer. You want to engineer the car to do things based on this situation. What's your choice? Number one, you can hit the 5 kids. They're supposed to be not working there. and you become safe. Or you can actually go turn around because there's no time for you to actually, hit the brake, let's assume.
Yeah.
Turn around and kill the driver
Right.
to save the 5 kids. If you are the engineer, to pick between these two ways, which way is, ideally, you should be able to hit the brake, right? But for extreme cases, which case are you going to take?
Kill the driver.
Kill the driver?
Yeah.
Why?
Because if they hit the 5 kids, it becomes a bigger issue. More people.
What about
are
2
hurt.
kids?
More people are hurt.
1 kid?
It's an
1 adult? 1 female? 1 male? 1 dog? Can you see the problem here? Like, where's the boundary? That's number 1.
Yeah.
Number 2, if you buy a car and you know the car is going to choose to kill you in this situation, are you going to pay for the car?
No.
It's like the first thing you came to buy this car, they say, hey, this is a agreement, you need to agree. Well, in that situation, your car will choose to kill you. I will say, okay, sorry, I need some other car.
Right.
I won't buy your product. So it's actually an ethical question. Even though your machine, your algorithm doesn't make a mistake, but at hard decisions, how do you quantify those kind of decisions? For humans, it's even difficult.
But then what if that scenario happened over and over again and your car kept hitting those 5 people? You would still be blamed.
That's the
Not
problem.
the car.
Like, I mean, at my level, I only have that thing probably once a life.
Right,
But think
but-
about the company. Probably they sell 20,000 cars. Every year, probably they got reported for 20 cases like that.
Mm-hmm.
Right? That's the thing. Like, that's why I say, like, this is a conflict cases. Like, people need to think hard on how to deal with this kind of ethical questions. It's actually the same thing with human decision. I don't know if you know about this. What's the hurricane back in New Orleans 10 years ago, roughly?
No idea.
Sandy, I don't quite remember, but either way. So you got a group of people who were trapped in the hurricane, right? It's whole flooded, and they were trapped in the hospital. So the electricity is out; they couldn't get out, so they got trapped there. After a while, all the doctors decided that they don't only have limited resource; they need to let the guys who are in risk, whose life is managed by system, go because just you guys need to die.
Mm-hmm.
We don't have enough resources. You face those kind of choices too, as a human situation, right? But now the problem is like how good you feel that you make this one automatic process. It's like if there is a hurricane and you will have a heart attack, sorry, we're just going to kill you by the procedure.
Mm-hmm.
Even you change the agent to be human, it's still a hard decision to make. So do you want to give people a manual, say under this condition at the doctor training, you can kill patients? See that? See the conflict?
Yeah.
So actually it's not just a machine and human difference. It's also like even if human make decisions at this kind of extreme cases, do you really want that thing to be a concrete process? That is every time you make exactly the same decision, or do you want to allow some, ethical quality of that person, or something, let him does some decision based on his best judgment, or do you want to make it automated? Okay, that's an interesting thing you can think about. Yeah. Now back to the buying cars, self-driving cars. Actually, it's actually the same thing with automation for everything. So I read something about Andrew Yang. He wrote a book about the war on normal people. So basically, what he claimed is one of the following 5 categories. If your job falls into one of the following 5 categories, you will be replaced by machine step by step. They are manufacturers,
Mm-hmm.
which already happened. 4 million jobs just disappeared after 2000.
Mm-hmm.
Okay, never came back. And I heard actually from some online forum that a lot of manufacturers in the United States is actually trying to freeze their positions. It's basically like we don't hire more, okay, and we're not going to lay people off. But if an old guy retire,
Just
the
pause.
position is done.
Yep.
The position is done, right? So manufacturer is one. Retail is another one. Think about how many retail stores just closed. Like, if you go to any places, ask them, like, do you have local store closed? Everybody's going to raise their hand and say, yes, mall is gone. Like, think about the mall in La Crosse. It's basically gone,
Yeah.
right? And
Well, with that, now it's all online shopping.
yeah,
That's right.
Amazon is actually crashing everybody, right?
Yeah.
So that's retail, and then waitresses, truck driver, and finally the phone services, which I have a personal experience to share. 2 days ago, actually, last week I lost my wallet. Okay, so this is the first time in 5 years I have to call in American Express to report my card was lost. This is the experiences. So I called. They say, please say what you're calling for. I said, lost card. They say, okay, just to confirm, is it lost or stolen? Lost.
Mm-hmm.
What's the last 4 digits of your social security number? I tell them the number. Are you calling about the card ending in this 4 digits? They tell me the digits. I say, yes. Okay, we are going to send you a replacement card. will you be okay if we send it to the address ending in this? I say, yes. Is that okay? Our card arrives before October the 8th. Does that work for you? I say, yes. Okay, just to confirm, you're calling for a lost card ending in this number.
Mm-hmm.
We are going to send a replacement card to this address by October 8th. Is that correct? I said, yes. And then done. The whole process took me 2.5 minutes. Mm-hmm. I'm so much happier than just, before I call to customer service, it's done by human. They always have this procedure which they can barely follow, Yeah. And anything that is not included, they basically say, I need to call my manager. Usually I spend I don't know about your experiences, 35 minutes. It's very
waiting.
Right?
Yeah.
Waiting, and also you call somebody, they say, I don't know, let me find my manager.
Right.
And you can actually hear how many times these people are not well trained at all. They don't know the menu, right?
Well, they do the same things with refilling prescriptions.
Yeah.
You call.
Yeah.
It's automated. They say, what do you want? Refill.
Mm-hmm.
Type in the prescription number.
Mm-hmm.
When do you want to buy? Hang up the phone.
Yep. So that's actually another big part which is going to be replaced by machine, step by step. So the manufacturing is already happening, and has already happened.
Yep.
It's going to continue to happen. And phone services, I think it's happening really, because 5 years ago I didn't expect. Before I was frustrated with calling.
Right.
They could never understand what I mean.
Yeah.
Right. But now it's super great.
Mm-hmm.
And then the rest is just all the other three fields I talk about. They're going to be replaced. That's what Andrew Yang was claiming.
Waitresses, though, at what you said before, at the fancier restaurants, you do expect a person to be there. So how is that whole industry, the restaurant industry?
When we say replacement, we never talk about the whole industry. We talk about maybe 60% of the people. You just don't need those many people anymore. Have you been to McDonald's recently?
Yeah.
Have you seen how they start to automate things away?
Yeah, it's also interesting because at certain McDonald's, there's a walk-up window. So you don't even have to, you type it in on a touchpad.
Yep.
And then your food comes, so you don't even have to interact with anyone.
You take iPhone, you can actually order it and pay with Apple Pay. You don't have to talk with anyone. You got deals, right, for doing that. You even have 3 parking lot outside, which basically you order. You say, I'm in parking lot 5. They are going to actually come out and give the order to you. So do you think this one is going to lay off at least a few employees with McDonald's?
Yeah,
So,
especially fast food.
Yeah, so fast food. So I'm not going to say good restaurant, big restaurant, of course. And also for phone services, there will be certain kind of premium phone services. You just have a complicated case that machine cannot handle. But think about this. If a machine can handle lost card, how many percent of the phone call they can reduce? Just think about it. I'm just going to make a guess, 10% of the phone call or even 20% is about lost card, right? I'm not going to replace some guy who can actually make a decision to increase my credit limit or, give me some kind of membership. That's probably still not replaced by machine, but for lost card, why not, right? So you're going to replace not the whole industry, but a big amount of it. Same thing with manufacturers. Are you going to replace everybody? Of course not. There are complicated machines, which humans are much cheaper and much more capable. But if you're just going there on assembly line, all you do is just do this, turn around, do this again for 8 hours, you may be in trouble because number one, machines are cheaper. Number two, actually machines are easier to handle. They don't have emotions. They work 24/7. They rarely make a mistake. They don't get tired. And for example, if I go to the job today, I just feel a little bit sick, or I had a big argument with my wife, that's going to affect my quality. And if my quality got affected, probably if I'm doing car assembly for a small part, the whole car got affected. But now if a machine, they don't have those kind of problems. So you can see why, all these companies, if they could, they want to do this.
Interesting.
Right, so when you interact with people, back to the experiences thing, right? If you fall into one of these 5 categories, I believe what Andrew Yang said, because he may not say the right thing, right? But I think he captured the point. Automation is going to be a huge, I won't say problem. It will change our life. It can be the positive. It can be negative. It really depends on how the government and how the companies respond to it. Yeah, and the normal people has to respond to it too. Another depressing fact for you to know. Really interesting. I took a psychology class online, and I know there is an interesting, I won't say correct conclusion or anything. It's just an interesting thought about psychology. That is, there is some number called IQ, right? Everybody knows about that. IQ is actually one of the few psychological factors that can be measured super accurately. That means if I say you have an IQ 120, the other guy has a IQ 118, then probably you're smarter. Okay, it's very accurate. It was born with. So if you are born with a high IQ, you could never be trained. Okay, so that actually comes with your birth. Now, how complicated a task you can accomplish is directly very high correlated to how big or how high your IQ is. So what people did is actually they try to put the job categories into different IQ level. So if you have an IQ more than 145, you can do anything. Anything complicated, creative. If you have something from 120 to 130, 110 to 120, you're only good for this kind of jobs. Those jobs will be too complicated for you, and you keep going, okay? And then an interesting conclusion is, or finding was, or guess was, in modern society, there's no job that is easy enough for people with IQ lower than 90. And we're talking about 15% of the population here.
Wow.
And you can try that. Psychologists actually did some experiment. They basically try to teach the some low IQ people, to use a cashier machine. Like, how hard can it be? Right? That's the same thing I ask myself. Like sometimes I see some guy just mess up with the machine. It's just like, the only explanation I can come up with is just you're not paying attention, because that's so simple, right? Mm-hmm. Regular things take you 5 minutes, 15 minutes to learn. It will take them 40 hours. And after that, they constantly make mistake. Okay, so that means you cannot trust them. So where will these group of people go? Basically, what they do is, if they're male, they develop depressions because you found a job, you got fired, you mess up, or after a while, you just drop out of labor force, right? You don't feel good because you feel like you need job, and eventually you develop depression. Mm-hmm. Once you have depression, you have pains all around your body, and you need to actually be prescribed for painkillers. Mm-hmm. And those 2 painkillers for this kind of pain is covered by insurance. I don't know if the government knows about it, but probably the governments at least know a lot of people are having this. But actually, this may be the cause. That is, they couldn't find a job simply because their IQ is not high enough. Now, if you think about automation, where is automation trying to replace people? My guess will be it will replace by the IQ level. It's like lowest, and then now we're looking at probably 90, right? Mm-hmm. Maybe 95 next, maybe 100 next. So that would be my guess. This is like a hypothesis. It's not being verified, but this will be my guess. But then, if you think about it, it's actually not a difference between white collar or blue collar. It's more about how complicated the thing you do. For example, you can be a white collar, sit in some office building, dress really well, but doing some redundant, boring stuff, which doesn't require intelligence. Or you can be a very hardcore manufacturer person, but operate really complicated machine. Mm-hmm. That is actually much more complicated than a white collar's job. Mm-hmm. So it's not like the blue collars or the manufacturers are the dangerous ones, are the ones in danger. Actually, it really depends on how redundant your job is, and how many human part you have in your job. Because if you think about it, when we train people to be efficient workers, we're basically trying to train them to be like a machine, right? Like, for example, you work like a cashier. Okay, what's the best compliment that people can give you? Well, you order really fast, right? Mm-hmm. So if it's fast food, you order really fast. Can it be faster than a machine? You're basically trying to train yourself to be a machine. So don't be surprised when you got replaced by a machine, right? So that's why I say, like, the human part is probably the part you want to work on. People want to help each other. People want to talk to each other. So next time when you go there and be like, order food with our people, probably smile will make you one step further from being replaced by a machine, other than just giving them a face like, say, okay, order number. What do you want? Combo or meal? Yeah. It's just like, okay, I can quite see, like, why do I want you to be replaced by American Express or, machines? Yeah. Yeah.
Interesting.
The IQ thing is pretty depressing, right? Yeah. The first time I heard about it, it's like, okay, yeah, that was sad. this is crazy. That's actually why they banned the IQ test when you go to an interview. Yeah. Like, they cannot test your IQ.
So it's just like the lower the score, the basically, more likely you are to be replaced.
Yeah. Or just like the less likely you will be able to accomplish a complicated task. Yeah. For example, like if you want to do mow the lawn, probably you need some IQ. But if you are lower than that, you cannot even use the lower mowing machine. Yeah. Otherwise, you may hurt yourself. Mm-hmm. Yeah.
So I don't know if you've been reading some articles about Netflix recently, but now it's within like one of the top 5 biggest media conglomerates in the U.S., right? Mm-hmm. So they're producing more media, like podcasts, commercials, everything other than just film. Mm-hmm. And they're maximizing their profit this way by investing in other types of media. Mm-hmm. Now, some companies use their media in just one type of industry, right? Like they only make music, they only make film, stuff like that. Mm-hmm. It's kind of off topic, but what do you think the advantage is of investing in more types of media in the long run.
Mm-hmm.
Do you think that can relate to some sort of bigger data to be there? And how can we use that? Does that make sense?
Yeah, that makes sense. So I'm not familiar with Netflix that much, but I do know Spotify, which are basically doing the same thing. So they started with music. Now they're actually investing in podcast.
Yep.
Right? So think about if Spotify comes here and try to play with podcast, and what advantages do they have? Number one, they already have done all the machine learning with songs. It's very easy for them to actually migrate that algorithm directly into podcast about people's playlist, the play time, the part they drop out, all this kind of analysis they have done before for music. Now they can do it for podcast, right? So this is what I would argue is actually because these things are different medias, but their business model can be actually shared, like podcast across different type of medias. Like the business model may be the same or at least similar, right? But since you're already, like Spotify already thrives in terms of like music, I think for all the technology issues they have in doing podcast will be exactly identical almost to what they had in music. So they will have a huge advantage of doing that. And they already know how to actually analyze people's preference, try to mine the similarity between music, similarity between users from their playlist. They also try to do something really interesting is actually they were trying to create a platform where people can write music together. So it's more like, you write 15 seconds. Is that a good song? Is that a bad song? Well, why don't we just give other people and let them listen to it? I'm going to tell you when they drop out. After 13 seconds they drop out. Then probably you want to add something there to hook people up, right? So actually you can do this kind of, it's almost like a GitHub for music, right? So they're doing all these kind of things. I think migrating to podcasts can be really easy, going from here to here. Plus, if Spotify launches a podcast, what do you feel? It's probably going to be good, right? If I launch something called, I don't know, Spotify, you would never use that because where is this, right? It's the same thing like for example, when Tesla make cars, right? Like who wants to buy a Tesla? Nobody, because I don't know this company. But if Tesla already did a reputation in terms of racing cars, like if they can make racing cars, of course they can make a $30,000 family car, right? The same thing with Mercedes. If Mercedes give you a smartwatch, like it's Mercedes branded smartwatch, how good is it? It can't be bad, because Mercedes, if it's bad, why do they do it?
Right.
Same thing, right? So you already have this kind of the brand quality, the brand worth. So that is going to make a huge impact on that. So that's why I say like for Netflix, it's really, they are doing things at a different level because they are using the business model and the business experience they extracted, and it has been validated and experimented as an internet company. While Paramount, all these kind of old, like Disney, I don't know about Disney actually. Paramount, I more feel like that, like Paramount, 20th Century Fox, and Sony. All these companies are still doing things in the traditional way, and no surprise, just like all the more are killed by Amazon. Yeah, I think Netflix is going. Think about how fast Netflix grows, right? And how amazing the stuff they're doing. Yeah. Do you believe that you can pay $10, you can watch whatever movie?
It's like $13.
$13? Yeah. For whatever movie 10 years ago, where we still have the Blockbuster. Right. Or Blockbusters? I don't even know. Yeah, I had a membership for 1 month and a half, and then they went bankruptcy. I did that. So that was really bad. Like Go Hastings. I don't even see a Go Hastings here. It's like, how are you supposed to survive? Right? So people are doing things from internet, and they are using high tech, and they're actually making films. Like probably heard about it. Like Netflix are using big data to actually find the right story, the right actor and actress, the right director to make a show so people will like. So it's almost like I know you guys are going to like when I put this group of people together. Yeah. Of course, that's a different problem. That is like, how much can you engineer media to fit people's need or just hook people up? Think about YouTube, right? Do you feel like for nowadays it's really hard for you to quit YouTube? It's just like you watch something for 6 minutes. Oh, this is so engaging, so interesting.
You stay on it for 3 hours.
Yeah. Why is that? Because we know what you like. Like the next 16 media I recommend to you is definitely going to be interesting, and you're going to like them. And plus, if I make videos, I know if it's 8 minutes, that's the right length. Yep. Longer than that, you cannot pay attention. And I know that at 2 minutes, 20 seconds, I need to put some bomb there. And then another 3 minutes, I need to put some bomb there. Because the data is so big and it's so simultaneously updated, they can actually start to do social experiments with all those kind of big data. It's just like how many people drop out after 2 minutes. For one people, that's probably special. If I have 2 million users, 1.5 million drop out after that. Right. I probably want to edit my video towards that to hook people up. So it's almost like they are building content according to people's need, or at least to your biological and neural needs. It's like you find it so addictive. Mm-hmm. You cannot quit simply because your brain is wired in this way.
And you know what's interesting is what you watch on YouTube and everything that you Google,
mm-hmm.
that will come up as advertisements on all your other social media apps.
Yeah.
So that's also another form of AI in a way. It's teaching.
This actually it's purely AI. It's machine learning because it's handled by big machines, right? But now here's the problem, right? As a person who go online look for news, and if they know your news preference, do you want to hear the things that you always like to read? Is like, I hate a certain person. Everything I search about that person is going to be negative because they know I hate that person. Mm. Do you want to keep reinforce yourself towards that? Or do you actually want independent opinions generated by individual artists instead of towards your need? So you start to see new stuff. You start to see new creative stuff, which is against your opinion. Do you want both? Who decide the boundary? Who decide the percentage? That's the problem. What if they can actually make you so addicted to YouTube? How about they can actually make you to accept certain kind of opinions, which is almost like a propaganda, right? And Facebook was charged for this. Mm-hmm. Basically, there was a company, I think it was called Cambridge Analytics or Cam Analytics. Basically, what they did is actually, psychology, you have some personality trait which is called the Big Five model. You kind of say, hey, in 5 dimensions, people are different, right? So a study showed that people who are high in conscientiousness and low in openness tend to be the right politically. Okay, and people who are high in openness and low in conscientiousness tend to be the lefties. Okay, the left. Now, if you go on people's Facebook, what they did is actually they go on Facebook and they retrieve all the data from Facebook about a person's page, use that thing to predict your conscientiousness and openness level. And then you will know who are predicted to be high and low, and low and high. And then you can predict who is more likely to accept some left Democratic candidates and who are more likely to accept somebody from the right. And then you start actually to push them news and to push them a little bit in that direction. Then it's almost like you are manipulating people without people alone knowing, right?
You're enforcing their opinions with those advertisements.
Yeah, so you can start to do that. Yeah. Like that's what advertising is. Yeah. Make you buy something you don't want to buy, right? Yeah. But to what end? Like you're too far away. Same thing with YouTube. Like if you use some biological content, it's like your brain keeps generating some kind of dopamines or hormones just to make sure that you couldn't quit. Mm-hmm. It's like so addictive, right? When you design games, it's the same thing. Whenever you want to quit, they give you something to make sure your brain got hooked up, right? To what end? This one become like you're manipulating people. Like people become addicted. I hate this game. I just can't quit. Like this happened to Flappy Bird. It's like a very stupid game, but people write really bad reviews about it simply because I couldn't stop. It's such a stupid game. I spent 6 hours on that. Yeah. That guy becomes so frustrated. The guy who invented the game, he actually took the game out of the app. Just said I couldn't take it anymore. He made tons of money because once people got hooked, they never stop. Right. But he just mentally I can't take it. Right. It's just so hard. So that's the hard part. So this is the interesting thing with nowadays with internet and medias, right? Do you know this like Facebook and Snapchat are all free? Yeah. Right, free to use. That is because like if everybody is free, then they don't compete with product qualities. They don't compete with prices. They compete with your attentions. Mm-hmm. So what's the best business model? What's the most successful company? The ones who can grab the user's attention the longest. So they have to do things in this way in order to win the competition in terms of like a market. But don't you feel like this is actually working against you instead of working with you as a user? By the way, user is really interesting. Nobody call their customers users except for internet company and drug dealers. Like you go to a restaurant and everybody say, hey, welcome user. What do you want to order? Do they say that? No. Only 2 companies, if you go inside, internet companies and drug dealers, they call their customer users. I don't know if that's a coincidence or, you don't call some people the user of a certain kind of washer and dryer, right? Right. Yeah, so.
Interesting.
Yeah.
With what we were talking about earlier regarding politics, I think it's interesting because everyone who who talks about it online
Mm-hmm.
is usually very, very opinionated one way or the other,
Uh-huh.
right? So the things that you search and the things that you're interested aren't like how to be in the middle. What, you know, what's the middle ground of the situation? If you're talking about it on social media so, you know, profoundly, then you're either one way or the other, right? So
Mm-hmm.
if you're looking at those things, how do you think, and so the computer sees you, you know, you're swayed left or whatever. The computer sees you, you're swayed left. They're going to give you those advertisements. What do you think would happen if they continuously saw advertisements that were swayed to the right?
Mm-hmm.
You know, and it did the opposite way.
I mean, I won't say what will happen, but we pretty much are certain that the company has those kind of information.
Mm-hmm.
It's just like up to them. Do they want to use it or do they not? How do you feel about that? Right? It's not like they have a way, they are definitely going to do this or they're definitely going to do that. No. But it's up to them what they want to do.
Mm-hmm.
So that's actually the scary part. Like, what if they don't pick the right side or they
right.
start to pick side even?
Okay.
Right, so that's a problem. That's why like a lot of people are calling to like, you know, this, we need regulations on this. We need, you know, this company to sign a certain kind of agreement. There are certain things you just shouldn't be touching, and also there are certain things when you do, you cannot do it beyond this level. Otherwise, it's basically you're controlling people, right? So that's actually a big regulation problem, and yeah, that's a big problem that need to be solved. And also as a user, we need to actually develop our self maturity to see something and realize that's just on the internet.
Right.
Like for me personally, I think it doesn't make any sense to argue with people on the internet at all.
But people do.
But because all the information you receive are biased. You don't see my facial expressions. Right. You don't see my like attitude and everything. Maybe I was just trying to joke about something, but I just, you know, didn't type in a smiley face. Something you think is insulting, right? So why don't we just do it in person? Even doing it in person is pretty intense. Right? What about online? And of course, online, everybody picks simplified informations. They only see the part they want to see. Plus, what you said online, stay online.
Yeah.
Right? People can quote, well, that's not what you mean because 3 years ago you did this. So are you a man of your word or not? Right? So they have record all the way backtrack to on your social media. That's why I don't feel safe of doing this because people grow. Like they make dumb mistakes when they're 16. But when they're 30-something, you shouldn't accuse them for something they said 14 years ago. But people tend to do that. Right. Plus, I think a lot of argument online is just meaningless. Like, what are you trying to do? Make your point so other people are going to change their mind? Are they going to change their mind? Or are you just saying what you want to say? It's actually the same thing with talking with other people nowadays. It's harder and harder because it's really hard to find good listeners. You feel like people just want to talk their things. And when other people are talking, they are basically sitting there. You can tell they're preparing what they want to say next.
Right.
But they didn't listen to a thing you're saying.
Especially if it's something that they don't agree with. Or
they're trying to destroy you.
Right.
They're not trying to destroy your point. They were trying to prove they are right, not their point are right. Because I think the only way I can learn, I can think is actually through people attacking my point. I say, well, actually, you do have a point. I never thought about that. My opinion needs to be strengthened, right? That's actually the healthy relationship in terms of conversation. But usually people nowadays, they just don't do it. They just repeat. And if you simplify everything, it's just always like repeat a single word.
Right.
Just like racist. Now you start to have those kind of like ideology possessed person, which is really difficult to communicate with because they're not here to listen. They're here to speak. And for me, I just walk away.
Yeah.
Yeah. I mean, I will talk with you if you're willing to listen.
Right.
And if you want to talk with me, want me to listen, I can listen. Right. So really healthy suggestions for younger people who want to avoid this kind of, because you have emotions, especially when you have a group of males sitting together, they're trying to be on top of each other. It's like you said something, I'm going to say something to make you look stupid, right?
Yeah.
Pick a nice room with nice temperature so you're in a good mood, and always start your conversation with a question instead of saying make a statement. Start with a question. And then whenever everybody says something, they finish their discussions, you repeat what they say, summarize what they say, starting by, did you mean, if I'm understanding correctly, you mean this, and that. This is actually a healthy way to build relationships because in this way, people see, oh, you're serious about discussion, and you clearly paid attention, and the number 3 you summarized was not correct, so I'm going to actually add more on it.
Right.
In this way, you reduce the misunderstanding. So after a conversation, both parties should feel better. I understand things so much better. No, doesn't matter who wins, right? It's just like your opinion become better, mine become better too. So now we may still don't agree with each other, but at least we start to strike more fundamental differences other than I just misunderstood what you just said.
Yep. I mean, and it's proof that you're listening.
Yeah.
And they like
So
that.
I think that's a really nice thing, but it's rarer and rarer to see people having these kind of conversations.
Right.
That's actually part of the reason I want to start a podcast. I want intelligent conversations. I don't want to just, I mean, chit chat is one thing, but we got so many smart people on campus.
Yeah.
Right. So
I think it's a good idea.
yeah.
I also wanted to ask one more question about Netflix.
Uh-huh.
So,
Are you trying to promote anything here?
No.
Because this is not a commercial podcast. They need to pay
Not
me to
paired
do
with
this.
them.
Yeah.
So in recent years, I've seen that social issues have become more and more important and more talked about, and the awareness for those issues have been just more popular in general.
Mm-hmm.
And if you really look at the content that Netflix is purchasing, specifically, just films and TV, it is all revolved around diversity and social issues and mental health and things like that. So do you think on top of, purchasing podcasts and commercials and other things to promote the Netflix, do you think that they're also looking at what people are into and what they'll actually watch to get more viewers?
Definitely, that's actually the same thing. Like, if I know you're hooked up to this thing, I give you more of this thing, you're more likely to subscribe to my services, right?
Yeah.
So because they are not a media company, they're not like a CNN. Like, clearly there is some idea CNN want to give to you, which CNN believes.
Yeah.
But Netflix just doesn't care. It's just like, if you guys want to watch this, I do this, right? So yeah, I definitely see a reinforcement on that, and that's why I say like, if you have mass production like this, you're basically taking people's collective wisdom, collective unconscious, and project them onto a film to let people re-see it. It's almost like, yeah, I know this before. Now I see it again to revalidate what I just believed. For me, it's really sad because I want to listen to different opinions. I want to listen to the opinions that I could never imagine of. I don't want you to come here and just give it to my taste, everything, because only in this kind of way can I learn, right? I can only learn from something I don't know. If you just tell me what I know, what's the point?
Yeah, why watch?
Right. So that's why I say, like, if you see internet company, that's more like Netflix is doing. It's very different from traditional media. Traditional media is actually different. They actually see something, no matter it's the same as yours or different as yours, but we do take a stand. We do take a side. Now we say what we want to say. Right? But internet company, so far, I don't see any, like, they don't take sides, I would say. Yeah. But it's more and more, it's harder and harder now, because if you go on Twitter, you go on Facebook, and you go on Netflix, actually the same thing, right? So, not the same thing, but similar. It's just, you can see all these companies now, they're starting to pick sides. Like, for example, Google, left, firm, right?
Yeah.
So some people got fired in Google just raising a question about gender equality. He just got fired for, not for no reason, just fired for saying that. Not even saying what we should do about gender equality, just like, this thing, can we discuss it? And suddenly he got fired. That was like 3 or 4 years ago, engineer, very young people. So starting from there, I see all these kind of facts. I don't trust anything they say anymore. It's almost like, it's sad for me, but I don't trust it. Yeah. It's simply because I feel like, wow, I really cannot watch anything CNN or NBC does nowadays. It's just like, are you guys listening to yourself? I mean, if you want to do propaganda and brainwash, at least make yourself self-consistent. Don't say something contradictory to what you just said 10 minutes ago. Right? It's not the right way to do stuff. Yeah. But so that's my opinion on this. It's just like, I feel like Facebook and all these kind of companies, they are taking sides. Yeah. They're taking sides. So I don't know where this is going. Hopefully, eventually. I just don't know. Because the internet is so powerful. Yeah. All these companies are so powerful. Yeah, it's really hard.
Now, what about video games, not just social media? Do you think the owners of those games take sides too? Because I think I've previously talked to you about the game Overwatch. I don't know if you've played.
I don't play. I hate that game, but I know what that game is.
But some of the things said in that game can imply that is sway left based on the owners.
Are you talking about the game? developer, or are you talking about people say what the players say?
What the players say.
in online chat.
No, just
The characters.
the automated. Yes.
The characters.
Yes.
Okay. Yeah, I mean, people love to take sides. Let them take sides. If you don't like it, just don't play that game.
Yeah.
That's basically my opinion. Just I always think about like, I don't know, like if you're a gaming company, just do a gaming thing.
Yeah.
Like, why do you care about all this kind of thing? You're not in a position to talk about this, but
Yeah.
that's more like a traditional Chinese opinion. It's just like, when I grew up, I never thought politics is my thing. It's just like, I don't care.
Right.
What can I do about it? Nothing.
Yeah.
And if it comes, if I think about it, it bother me. So why don't I just don't think about it? Okay? If you're a video game company, make enjoyable games. Same thing with Naughty Dog, like a game company who actually developed most of my favorite series, like the Uncharted series and also The Last of Us. I mean, you got a group of young kids working at the company. Like, they are young blood. They are passionate at creating things. And most of young people are actually more leaning towards the left. I think it's fine. Yeah, so I don't see it as an issue. Yeah, but my thing is just like, I'm trying to find a way to escape from all this kind of opinions. Just like, can't you just let me sit down and enjoy the game quietly without telling me what's right and what's wrong? Right. I want to see the human part. I want to see the humanity part instead of like ideology part.
Yeah.
But it's harder and harder.
Now with video games, some of the players can make 6 figures a year.
Mm-hmm.
Isn't that crazy?
Oh. Do you watch Dota? Do you know Dota?
No.
Okay. Dota is kind of a game which is very similar. It's a 5-on-5 MOBA, and it's 5 against 5. They have an annual biggest tournament happens in August this year, and the prize pool was, I don't quite remember, 40 million divided by like I don't quite remember. It's like several $1 million for each player to take home for the winner. Oh. So it's not 6-figure anymore. It's 7-figure.
Yeah.
Yeah, I don't think that's crazy. Like, tennis players make how much? I don't know. But like soccer players, football players. Yeah. If you want to say the video game players make that much money, you should look at all the sports stars. Like, what's the difference? Like, what's the difference between sports and video game? Just different group of people watching, of course. Yeah, but what's the difference? Like, why do football players make so much money? They don't even have to be good to make so much money.
They just have to be on the team.
Yeah. And, I mean, you have top teams make big grants, but you also have small teams who also make decent monies. Yeah. Why is that? Same thing with video games, right? So I don't see anything special about video games compared to sports. Yeah. Right, so. Okay. Why are you so interested in video games?
I like playing video games.
What do you play?
Overwatch.
It's
the only one I play.
Are you good?
No.
Oh, okay.
It's just fun on the side.
Yeah, one thing I hate about online gaming, like collaborating with people or working against people, is just like trash talks. It's just like so, like I just mute everybody every time I go on. I don't want to come here and. Yeah. That's very interesting because I play a lot of video games when I was like a kid, and I play along my way. So I'm still playing video games like crazy, but I developed my own taste. There are certain games that I just don't touch, and I just don't know. Like, I cannot tell you what game is good game in my taste and what game is not good until one day I read the book a psychology professor recommended me, and now I have the terminology. I want to play the culture significant games, which means, for example, God of War. You play that, you actually know a lot about Norse myth. You do have a storyline. It's very touchy. You learn about father and son. You learn about all these kind of relationships. It's almost like watching a movie but for 40 hours. But you kind of participate inside, and you actually got the control you got the control of the pace, how fast or how slow you want the game to be played, right? So that's actually, for me, the next level compared to movies. Another interesting game which is called Dark Soul is one of my favorite, okay? And then they have like Dark Soul 1, 2, 3, and Bloodborne. And then, wow, this feels more and more like a commercial promotion, but... And then we got Secular, right? The same producer. But what he did was really interesting, is in that video game, he has reading... How to call that thing is like he cannot read linearly. So this producer has a problem. It's like a symptom. I don't know what that is called.
Oh, dyslexia?
Yeah, something like that. Yeah. So he has those problems. So he cannot read like linearly. Yeah. But somehow he ended up writing the story of that game. So what he did was actually he write a game about what happened, and then he started to actually take out pieces. It's like, I don't tell you the reason why people did this. I don't tell you who did this. And then whatever left is just like little piece of information. It's like you go there, you'll see a guy lying down there wearing a certain kind of uniform. You don't know why he's there. You don't know why he died. Okay? And then going in the game, you are kind of exploring and seeing all these kind of facts. And then all these players start to backtrack and they try to guess what the story is. As why is he here? Okay, with this kind of uniform, he belongs to which kind of force? And why are they sending a person here at this particular location? Why is that statue doesn't have a head? Okay, it's like, for example, the Lord of Light, Gwen. He has 3 sons. He has 3 child, 2 sons and one daughter. They always talk about the second daughter is like the princess, the prince of the sun, and then the third son, which is basically like a not usually son, but they never talk about the first son. Why? Okay, so people start to actually find the trace in that game until they actually go to one part of the castle of Gwen. They found all the statue there doesn't have head. They figure out that's the first son. He must did something taboo that he got banished, and people stopped worshiping him. And actually, they found it at a very little corner in the third episode, the third generation of the game. They found a statue which has a head on it, and that was Gwen's first son. So it's like you start to see pieces of information. Nothing start to feel real. But in movie, you could never tell a story like that, because you cannot simply tell a movie with, here are the 5 pieces. Right. I don't tell you how they're connected. You go there and guess. Yeah. And the beauty about Dark Souls is there are a lot of things you are going to miss the first time you play. You just don't pay attention. The next time you play, you have already done the main story. Now you go ahead and pay attention. Oh, actually, there was a sword I never paid attention to. So actually, every time I played that game, I found deeper layers. Every time I play that game again, I found deeper layers. Something I haven't noticed before. That is some experience I rarely get from watching movies. So that's actually the first game in my life I started to feel like this is more than a movie, like a game. Because before, a good game tells a good story. It's basically you have a lot of movie cutscenes, right? Yeah. Connected with playable part. But this one is more about, well, a movie cannot tell a story in this kind of way. So that was really interesting for me. So let's say cultural significant games.
Yeah. See, when I play video games, I don't think about it that in depth.
I have played video games for long enough. I started to actually pay attention to those kind of designs. It's the same thing with movies. I watched probably 2,000 movies. I just got bored when I was in my undergraduate. Almost failed it. But but that's why after that I started to actually see a movie. Not only I pay attention to the story and everything, I started to pay attention to lights. How did they do the lighting? Okay, how did they actually set the stage? And then I started to pay attention to their clothes, how their lines are developed, lines are designed. Why did they pick this actor? If I'm going to pick, who am I going to pick? Right. I started thinking things more from like a technical point of view. After you see something enough of times, magically, your brain starts to abstract. Same thing with machine learning. You see data for enough times, suddenly they start to abstract. Okay, so that's the beauty of, our brain.
Yeah, very cool. So one last thing that I was thinking about earlier was, I've heard a couple people say to me, do you think the government is listening in on our conversations, right? Because, maybe we'll be talking about a product or something, and that advertisement will show up on our computer. Are they allowed to do that?
So, several things, right? Are you talking about the government or anybody?
Anybody, I guess.
Right. Number one, it's really easy to hack your phone. It's against the law, though. So anybody can hack your phone if they're abroad, let's say. So that's why Apple actually, Google, they work so hard on the security part, right? Yeah. The second thing you need to think about is actually all the companies. For example, if I'm Apple and you're using iPhone, am I allowed to actually collect a certain kind of information? Usually they write that thing into an agreement if they want to do a decent thing. But the agreement is so long, you never read it. It's just like, hey, scroll down, make sure you read this, click agree. So they stay away from like lawsuits and everything because I made a claim. But how many people actually read that? So it's actually a challenge for people because if you're not doing technologies, you will not be able to understand anything in that statement. Right, so there's a huge barrier. It's almost like you tell me what was monitored, but really I couldn't understand what you're saying, so I'm saying yes. So it's almost like one-sided, like blindness, right? So people are trying to work hard on that to make the agreement easier. And let me tell you several interesting things. The first one is actually I know an Indian company. So do you realize sometimes you take your phone and your phone just pop up, the screen just pop up without you touching it? Yeah. That was dark before, but suddenly that's in pop up. That means somebody is actually trying to access your phone. Usually. Okay? And that company, what they end up doing is actually they access your microphone. So they listen to whatever TV show you're trying to watch. And then they claim they're doing this for a media company. We don't want your privacy. We just want your like your preference on TV shows. So that's certainly something they can do. Okay. And there are some other interesting things. Recently at MIT, some group actually did a research on predicting your emotional stress based on your face. So if you put a camera there, they know actually you're sad, you're happy, with a very high accuracy. They also know you're stressed, or you're sick today, simply because computers can see much better than what we see on colors. So even though it's like you look normal, but actually from computer they can tell, okay, you look blue today, or like red today or yellow today, a little bit turning that. And also they can, based on that and the muscle movement, we can only process such level of information, but the computer can say, hey, your breath just speed up, So they can use that thing to start to predict things. But now things get interesting. Number one, can you use this one for, can you use this algorithm to tell if people are telling lies? Can you use that thing at the interview? Can you use that thing at let's say, the court trial? Just like, did you kill her? And suddenly your face change color, or you look normal to a normal person, but on the computer you're almost like naked.
Could they do that with just audio though? I don't think so. I think they would need the facial expression to.
They can do it with audio, just different level. Maybe it's not up to that accuracy.
Okay.
But my thing is just like, can you use that thing on the suspect of a murder? Just say, did you kill her? And then use that thing as evidence, or at least a factor on the court judge. That's one thing, right?
Yeah. Number
two is, a lot of companies actually found this group and say, hey, we want to commercialize what you just did. Now, some company come here and claim, like, we want to know people who are depressed. Then we can actually do something to make them happier, right? Make them life better. That's great. There are also some research shows that when people are depressed, they tend to buy more stuff. They want to purchase stuff online. What if a company take this, open your camera, see you're upset today, and then go to your list of Amazon wish list and find something and give you a 15% discount today? Are companies allowed to do that? Well, you may think like, I'm not that stupid, I won't let them use my cameras. What if they give you a camera for free and just say, hey, we let you shop with your eye? Like we do eye tracking. So you don't have to actually shop by typing anymore. You shop by voice, you shop by face, you shop by commands, like a facial command. And you got this $200 camera for free. All you need to do is when you shop, open the camera.
Uh-huh.
Okay, who knows what they're dealing with our data? Kind of makes sense here. So it's actually a very serious topic that is actually data security. And also even data ownership is like, you say something on Facebook, who owns that data? You? Facebook? Who owns that? Right? Should we be paid for doing that? Because Facebook does make algorithms to mine information from our data, so they have a better model. Should we be paid for generating the data? Right? That's a very interesting thing to think about. There are actually debates. Like, of course, like, then we don't use your data. We have millions of other people's data to use. What's your marginal addition to my model? Almost zero, because my data is so massive, right? So people can argue, no, you trade your privacy for free product. Otherwise, why do you think the product is free, right? We use your data. But there are other opinions about okay, since I'm generating so much data, it's generating value. Why don't you just pay me, right? Especially you're laying me off. Now everything I can do is just go online and play video games. But when I play video games, I test your game. I do give you some feedbacks. Why don't you just pay me, right? So people are actually debating on this too.
Interesting.
Yeah, so there's a lot of things to think about, and ethical is really difficult. And if you do something with AI, right, or machine learning, it's actually there are 4 things you need to consider. Verification, validation, security, and control. You actually need to have every single one of them, because now you have something which is such a big scale. You code a little bit, right?
Yeah.
When you write for loop, you say for from 1 to a billion, okay? You just misplace a number. How big the damage that thing is going to do to the system.
Messes up everything.
Right? So how can you even trust your model before you apply it? Because every time you click yes, no matter how many people reviewed it, it affects millions of people.
Yeah.
Right? How can you be so sure? So the first thing you need to do is called verification. You think your model can do that. Does your model really do that? Right? How big the chance that thing is going to make a mistake? That's number 1. Number 2, validation. You claim your model can do this, and your model didn't have a mistake. But does your model really address this? Maybe you use the wrong model, right? So that's the second thing. The first one is actually, did you build the model right? The second one is more about, did you build the right model? Okay.
Yeah.
And then control. What do you mean by security? What do you mean by security? It's basically you got all this kind of beautiful AI and Google got hacked. Or Apple got hacked. That's when people got millions of pictures leaked out. What are you going to say about that? Right, law case. That's pretty much what we can do, right? So security is actually a big thing. What if this is an automated weapon? What if some people hacked your self-driving car? What if they hacked your iPhone and your iPhone somehow has like a self-explosion button they can just hit?
Yeah.
What happens if we have that? The last one, control. Control is very interesting because you want automated system because they're so big and so fast, so accurate, and they're so, how to say, so easy to scale up, right? And they rarely make mistakes. But then you still need to have a human part, especially for weapons. Right? Think about this. I don't know if you know about this. When we have the Cuba crisis in 1962, we have a lot of submarine from Russia, right? So basically, at the last minute, all of them actually received the signal from the president. I don't know if the prime minister from Russia and say, hey, we're not going to do a war. Everybody received that signal except for one submarine. They lost connection to their homeland. They don't know what to do. So they do have a nuclear head in the submarine. You need 3 people to vote for yes to launch that one. 2 voted yes, 1 voted no. So that's the only reason we didn't have a nuclear winter right now, because one person really no. If that system is automated, you won't have the chance. Second thing, in 1983 or 1986, I don't quite remember, it's on the boundary of Russia, some guy who is basically monitoring the missiles from America. He actually saw 5 nuclear head launched through Russian, and they do have a button you just push down. All the nuclear head, Russian head in the world is actually going to go and hit their target. And basically, it's the end of the world. He needed to decide, do you want to hit the button or not? Okay. He decided no, because if the United States is going to attack us, it's not going to be 5.
Yeah.
Right. Basically, they actually went back. They found the AI, or I won't call it even AI, just the automated system, saw the glare, the reflection of the sun from the cloud, and think that is actually the glare from a rocket. So that was a mistake by the machine. Maybe 1 out of a million.
Yeah.
Right? Mistake. But if the human was not there, if the whole system was automated, it's just like, you see this, do that. End of story.
Yeah.
Right? So control is actually the fourth thing you need to think about. Which part you want human to take charge in control? Because human can make mistakes too, right? So how do we design the system? Especially for weapons. But even for AI or Facebook, because this thing is so powerful now. The scale is so big now. How do we make sure that we can control the thing? It's amazing. It's actually amazing that we haven't screwed up yet. If you think about it.
Yeah.
It's really amazing. Like any intern Facebook hired, if they end up using this intern in some kind of product, and this intern misplaces a comma, anything can go wrong.
Yep.
Right? So how do you even make sure that happens? So I'm constantly fascinated or amazed by human. Like, this is such a complicated thing, and you can somehow build it. That's amazing. So
yeah, it is.
So finally, is government spying us? Like, yeah. But what can I do about it?
Nothing.
That's the problem, right? You actually interviewed in our generations. Actually, I read this from a book recommended by the psychology professor I'm trying to interview next week on addictive technology. There's a book written by Sherry Turkle, and which is called Alone Together, recommended by him. And basically, Sherry Turkle actually talk about this in her book. That is, you interview a younger generation. They all know. Like, people can hack me, and the government can actually see what we're doing. But their attitude is just like, but there's nothing I can do about it, so be it. Like, I'm so small, why do they care? And if I have nothing to hide, and I don't want people to spy me, but if I have nothing to hide, then why do I even care? Right. So actually, the new young generation is leaning more and more towards that mental set, and she felt really sad. It's like, this is not what this country was built for. So is government doing that? My guess will be firm yes, but what are we going to do about it? My answer is just like, I don't care. Like, there's nothing I can do about it. No. Right? But people do say, like, this is not what the United States, the Constitution is for. Like, I won't say against, but it's not the value of the founding fathers. Yeah. Right? So, I don't know. It's hard to say. Yeah.
Interesting.
Mm-hmm.
I don't think I have any more questions for you.
Sounds great. So thank you so much. We got an hour and 40. I think that's a really nice place to stop.
That is good.
Yeah.
I think you need a theme song. or something?
I don't know. I can even sing my theme song, like create one by myself, so I don't have to pay anything. Yeah. Okay.
Okay.
Yeah. That's for today.